So today let us see the beats. I told you the waxing and waning of intensity of sound due to
Yes, yes,
the superimposition of
yes, sir.
two sound notes of equal frequencies. One, two sound notes of equal frequencies traveling in the same direction with slightly different frequencies. Okay,
Yes, sir. Yes, sir.
that's what I told you other day. So let us try to do the mathematical part of it and link the concept.
Yes, sir.
It's not coming. Yes. Okay. What is the serial number going on?
Sir, beats is 5 5, sir.
No, let us make it six. Okay.
Yes, sir. Sir, beats is 6, sir.
Hmm.
Yes, sir. Yes, sir.
So the waxing and the phenomenon of waxing and waning of intensity of sound due to the superimposition of two sound notes of equal amplitudes traveling in the same direction with slightly different frequencies is called as beats. Correct?
Sir, you gave a smaller one, sir. The phenomenon of waxing and waning of the sound intensity occurring periodically is called beats, sir.
Okay, okay. Actually, what happens is also included in this new definition, second definition.
Yes, sir. Sir, can you repeat it, sir? I'll write down.
Yeah, you can write the waxing, the phenomenon of waxing and waning of sound, waxing and waning of sound due to the superimposition of due to the superimposition of two sound notes two sound notes of same amplitude, comma, traveling in the same direction, traveling in the same direction with slightly different frequencies, with slightly different frequencies, with slightly different frequencies, is called beats. Is called the beats. So here, the first point to discuss is human ear has got a limitation. Two sound notes entering our ear must at least have a time interval of 1 by 10, that is 0.1 seconds for them to be distinctly audible. So what do you mean by this? This is our human ear. One sound note entered a frequency u1. Then the time interval between the first note and the second note to enter should be at least 0.1 second. Otherwise, what happens? Only this will be audible. The second note will not be audible.
Yes, sir.
So the minimum time interval between two sound notes entering into our ear so that they are distinctly audible to us is 1 by 10 second or 0.1 second. This is our human ear limitation.
Yes, sir.
Therefore, so the maximum time interval is minimum means to have a minimum time interval.
Yes, sir.
So time interval is minimum means maximum difference in the frequencies.
Sir, so like there are different frequencies, sir.
Naturally, na?
Yes, sir. Yes, sir.
So delta nu should be equal to nu1 difference nu2. You know, time period and frequency are inversely proportional. So this will be 1 by delta t. Means 1 by 0.1, that is 10. So the difference in frequencies of the two sound notes which are supposed to produce beats should be less than or equal to 10 always. So delta nu should be less than or equal to 10 Hz. So what do you mean by this? If delta nu is greater than 10 Hz, then no beats are produced. No beats are heard. They'll be produced, but our ear cannot hear. Understand?
Yes, sir.
What is the reason? The time interval between two successive sound notes which are to be distinctly audible to us. You are able to hear me because every sound syllable coming from me will enter your ear in a time interval less than equal to or more than this time interval of 0.1 second.
Yes, sir.
Then only you can hear the two successive syllables coming from me.
Yes, sir.
If I speak so fast so that the successive sound syllables are produced in a time less than this, then you will be hearing first one and you will be missing the second one.
Yes, sir.
Understood?
Yes, sir.
So this is about the difference in time intervals. And you know, frequency is the reciprocal of time interval. Therefore, the time interval is minimum means and frequency is reciprocal of time period. So if this is minimum, this should be maximum. Correct?
Yes, sir. Yes, sir.
That's why I said maximum difference in the frequencies of the two sound notes entering into our ear for distinctly audible should be how much? 10. Means delta mu should be always less than or equal to 10 Hz for the beats to be audible to us. Correct?
Yes, sir. Yes, sir.
So you can show the beat formation like this. This is one wave. Oh, here is x-axis. This is y-axis. Okay. So
Yes, sir.
these are the. This is one sound note. So this is T by 4. t by 2, 3t by 4t. So you have 5 pulses, correct?
Yes, sir.
5 pulses in 1 quarter.
Yes, sir.
Like this.
Yes, sir.
So here is a wave of frequency, say 20 hertz.
Yes, sir.
Okay. Then there is another wave of frequency 16 hertz.
Yes, sir. Sir,
Hmm.
sir, in the what are X and Y, sir? There. Yeah.
It is time,
Okay, sir. Sir, why?
displacement.
Sir, so it is the amplitude, sir.
Ah, yeah. Already we have drawn these graphs now.
Yes, sir. Yes, sir.
So here is another wave. Like this. This says nu2 is equal to 16 hertz. Okay.
Yes,
Same
sir.
amplitude, traveling in the same direction, but slightly differing frequencies. Nu1 is 20 hertz
Yes,
and
sir.
nu2 is 16 hertz. Then what is happening? They are superimposing on each other.
Yes, sir.
So this is how you will get. I'll show it in other direction. So this is how So what is happening? The intensity is increasing from 0. It is becoming maximum, again becoming 0, again maximum. Like this, the amplitude is increasing to maximum and decreasing to 0. Correct or not?
Yes, sir.
So here is A maximum. And intensity varies directly as square of the amplitude. So if A is maximum, intensity also is maximum. Here A is 0, therefore intensity is 0. Correct?
Yes, sir.
So whenever maximum amplitude is there, intensity will be maximum. Wherever minimum amplitude is there, intensity will be minimum. So thus, this is called waxing. This is called waning. Okay?
Yes, sir.
So when two progressive waves of same amplitude, R1 is equal to R2 is equal to R, traveling in same direction, superimpose on each other, then the intensity of the resulting sound wave will be increasing periodically, not non-rhythmically. Very rhythmically, it increases from 0 to maximum, maximum to 0, and so on. So this
Yes, sir.
is called as, this phenomenon itself is called as beats. Understood?
Yes, sir. Yes, sir.
Okay. Now let us see the mathematical part of it.
Sir, can you go a little bit up, sir? I didn't.
Okay.
Sir, a little more up, sir.
This one, huh?
Sir, the upper part, sir.
Okay. This one?
Sir, the human ear, sir.
Okay.
Yes, sir. Sir, what is delta nu is equal to, sir? Like the
Less than or equal to?
sir, no, sir. Upper part, sir. The
Difference.
max. Yes, sir.
Difference.
Okay, sir. Yes, sir.
Means nu1 minus nu2 or nu2 minus nu1. It can be anything.
Yes, sir.
This equation you can write it as y1 is equal to r sine omega 1t and y2 is equal to r sine omega 2t. Okay?
Yes, sir.
Completed, huh?
Yes, sir. Sir, sir, in this example, sir, the down part, sir, the red one. Sir, can you show what is waxing and what is waving, sir?
This is waxing. Means amplitude is maximum.
Okay, sir. Yes, sir.
So intensity is maximum. And this is waning. So amplitude is 0, intensity is 0.
Yes, sir. Sir, so this continuously happens in beats, sir.
Exactly.
Okay, sir.
Sivamani na? Sivamani. Yes. Okay.
Yes, sir.
Then third one. So we have the waves which produce beats can be taken as R1 is equal to Y1 is equal to R sine omega 1t. That is R sine omega 2 pi nu kada.
Yes, sir.
So 2 pi nu 1t. R sine omega 2t. R sine 2 pi nu t. So these are the equations of waves of same amplitude traveling in the same direction with slightly different frequencies. But the condition మర్చిపోకూడదు ఏంటది delta nu should be less than or equal to 10 Hz. Okay?
Yes, sir.
Yes. So because they are superimposing on each other, just like in stationary waves. Stationary waves గుర్తుంటే ఇది ఈజీగా అర్థమైపోతుంది. Superposition
Yes, sir.
principle implies y is equal to y1 plus y2. Okay?
Yes, sir.
So that is r sine 2 pi nu 1t plus r sine 2 pi nu 2t. So sine A plus sine B formula. This is
Sir, sin A cos B plus cos A.
sine of A plus B అయితే sine A cos B plus cos A sin B. ఇది sine A plus sine B. This is 2 sine A plus B by 2 cos A minus B by 2. అవునా?
Yes, sir.
సో ఇక్కడ A అంటే ఏంటి? 2 pi nu 1t. అవునా?
Yes, sir.
B అంటే 2 pi nu 2t. అవునా కదా?
Yes, sir. Yes, sir.
సో ఇక్కడ A plus B అంటే ఏంటో చూడు. 2 pi into nu 1 plus nu 2 into t by 2. అంతేనా?
Yes, sir.
అలాగే a minus b by 2 అంటే 2 pi into
mu1 minus mu2 into t by 2, sir.
అంతేనా?
Yes, sir.
సో దీనిలో సబ్స్టిట్యూట్ చేయి. Or if you take common, so it should be 2 cos 2 pi into nu1 minus nu2 into t by 2 sin 2 pi into nu2 plus nu1 plus nu2 into t by 2. Right, chalaga?
Yes, sir. Yes, sir.
2 cancel చేసే ఇక్కడ. తర్వాత nu1 plus nu2 by 2 is equal to nu1. Then what are you going to get? 2r cos pi into nu1 minus nu2 into t sin 2 pi nu t. That is y is equal to a sin 2 pi nu t.
Yes, sir. Yes, sir.
Where a is equal to 2r cos pi into nu1 minus nu2 into t is the amplitude of the resulting wave. Then
Yes, sir. Yes, sir.
And nu is equal to nu1 plus nu2 by 2 is the frequency of it. Correct?
Yes, sir. Yes, sir.
So this is the resulting wave equation. So
Yes.
Now conditions for maximum and minimum intensities. Kada?
Yes, sir.
This is 4. Maximum intensity. This is minimum intensity. Maximum intensity అంటే ఏమన్నా వ్యాక్సింగ్ అన్నాం కదా?
Yes, sir.
Minimum intensity means waning.
Yes, sir. Yes, sir.
And intensity is of course square of the amplitude.
Yes, sir.
This is 4r square cos square theta. What is theta here? Pi into nu1 minus nu2 into t. Antena?
Yes, sir.
So I will be equal to I maximum is equal to 4r square when cos square theta is 1. Antena?
Yes, sir.
That is cos theta will be plus or minus 1.
Yes, sir.
Implies theta is equal to n into pi.
Yes, sir.
Where n takes the values of 0, 1, 2, 3 and so on. Correct?
Yes, sir.
Cos 0 is 1. Cos 180 pi minus 1. Cos 2 pi 360 1 like this.
Yes, sir.
So ఇప్పుడు theta place లో దీన్ని సబ్స్టిట్యూట్ చేయి. Pi into nu1 minus nu2 into t is equal to n pi. అవునా?
Yes, sir.
Therefore, the time instant at which the maxima will occur is
N by nu1 minus nu2, sir.
n by
Nu1 minus nu2.
nu1 minus nu2. Avuna?
Yes, sir.
Means the times the instant of times. At which the maxima will occur are n0 పెట్టు, తర్వాత n1 పెట్టు,
Yes, sir.
తర్వాత n2 పెట్టు,
Yes, sir.
నెక్స్ట్ 3 పెట్టు, like this. అవునా?
Yes, sir. Yes, sir.
So time interval between two successive maxima ఎంత వస్తుంది? 2 by nu1 minus nu2 minus 1 by nu1 minus nu2. అవునా?
Yes, sir.
Or 1 by nu1 minus nu2 minus 0. Anything.
Yes,
So
sir, it is 1 by nu1 minus nu2, sir.
Exactly. Therefore, right. So the number of maxima per second is delta nu is equal to nu1 minus nu2. Antenna?
Yes, sir.
Coming to the minimum intensity.
Yes, sir.
I minimum is equal to 0. This is possible when cos square theta is 0.
Yes, sir.
That is, cos theta should be pi by 2, 3 pi by 2, 5 pi by 2, and so on. Then,
Yes, sir.
cos 90 0, cos 270 0, and so on. Implies theta will be 2n plus 1 into pi by 2. Kada?
Yes, sir.
So, same values bettu n 0, 1, 2, 3, etc. 0 పెడితే ఏమొస్తుంది?
Sir, pi by 2, sir.
1 పెడితే?
Sir, 3 pi by 2, sir.
And if you substitute 2?
5 pi by 2, sir.
Correct. Okay?
Yes, sir.
So, yes. Therefore, what can you write now? Pi into nu1 minus nu2 into t should be equal to 2n plus 1 into pi by 2. Then,
Yes, sir.
therefore, the time instant at which the minima will occur so t will be
Sir, 2n plus 1 divided by 2 nu1 minus 2 nu2, sir.
2 into
nu1 minus nu2, sir. Okay.
simple.
Yes, sir. Yes, sir.
So ఇక్కడ రాసినట్టే the instants of time at which the minima will occur are n0 పెట్టు.
Sir, 1 by 2 into nu1 minus nu2, sir.
తర్వాత
Sir, 3 by 2 into nu1 minus nu2.
and so on.
Yes, sir.
అంటే 0 దగ్గర మాక్సిమం వచ్చింది.
Yes, sir.
1 by 2 into nu1 minus nu2 minimum.
Yes, sir.
Again 1 by nu1 minus nu2 maximum.
Yes, sir.
అంటే between every two maxima there is one minimum.
Yes, sir.
So time interval between two successive minima delta t will be,
Sir, 1 by nu1 minus nu2, sir.
that's all. Therefore, number of minima per second, same you will get. Kada?
Yes, sir. Yes, sir.
So now we'll define beat frequency.
Yes, sir.
Beat frequency is defined as number of maxima or not and minima
Yes, sir.
produced per second. Therefore, delta nu will be nu1 minus nu2. This is the beat frequency.
So instead of maxima and minima, we can take waxing and waving also, sir.
Yeah, both are instants, time intervals are equal, na?
Yes, sir. Yes, sir.
So or means either this or that, because
Yes, sir.
both are equal.
Yes, sir. Yes, sir.
Yeah, this is about the beats, and they are used in mining,
Yes, sir.
and they are used in finding unknown frequency of a source.
Yes, sir.
And in music, production of music.
Yes, sir.
Yeah, mining lo entante sometimes harmful gases will be coming out.
Yes, sir.
So we have already the knowledge of resonance pipes. One end closed resonance pipe.
Yes, sir. Yes, sir.
Using that concept and Beats concept, they will be identifying based on the frequency of the reflected wave they get. So they will be identifying the presence of any harmful gases in the mining, etc., and then they will proceed.
Yes, sir. Yes, sir.
Okay. Have you copied or you want to copy them?
Sir, from superposition principle, sir.
Okay. Doctor effect is left.
Yes, sir.
Completed, eh?
Sir, 1 minute, sir.
Shall I scroll it up?
Sir, I'm about to complete, sir.
Hmm.
Sir, I'm about to complete it, sir.
Okay.
Sir,
Hmm.
so like we wrote sine 2 pi into nu1 plus nu2 into t by 2, sir. Why can't we cancel 2 and 2, sir?
No, we wanted to convert it into standard wave equation, na?
Okay, sir. Yes, sir. Yes,
That's
sir.
why I did not cancel that, because that nu is the frequency of the resulting waveform.
Yes, sir.
Yes, for that I did not.
Yes, sir. Yes, sir.
Okay.
Sir, 1 minute, sir.
Okay, now I'm saying.
Yes, sir. I'm doing it, sir. Conditions for the maximum and minimum intensity.
See, this is the beauty in physics. Logic with mathematics will give the perfect shape to physics.
Yes, sir.
Hmm. So this is the formula for intensity. I is equal to a square is equal to 4r square cos square theta.
Yes, sir. Yes, sir.
So you must know those trigonometry formulae.
Yes, sir. Yes, sir.
Okay.
Yes, sir.
From where you want me to keep?
Sir, I'm doing pi nu 1 minus nu 2 into 2, sir. Yes, sir.
Okay.
From here. Sir,
Okay.
it will be better.
Okay.
Sir, 1 minute.
I always prefer this comparison type so that you will have the clarity.
Yes, sir.
Hmm. Okay.
Yes, sir. Sir, can you go a little bit up, sir?
Is it okay?
Yes, sir. Yes, sir.
Finish that?
Yes, sir.
Shall I close?
Sir, a little bit up, sir. I'm able to-
Appa.
Yes, sir. I wrote until delta t, sir.
Okay.
Yes, sir. Done, sir.
Fine. Okay. Tomorrow we'll do Doppler effect, right?
Yes, sir.
Fine.
Thank you, sir. Good evening, sir.
Okay. Bye bye.